Okay, in this video I'm looking at the bisector of an angle. One definition is the bisector is the line that divides an angle into two equal parts, which we see here on the left. Very intuitive definition, easy to understand. A somewhat more abstract definition, which is also necessary to understand, is the bisector. It is the collection of all points which are equal distance to both arms of an angle. So I've got an angle here, I have the bisector here. The idea is that you can now take any point, so let's consider this point right here, and say that the distance from this point to this arm must be equal from the same point to that arm. The distances are the same as for here. Yeah. And the reason is by making this point, you can draw a triangle, and this triangle will be exactly the same. So there's this notion of distance from a point to a line. The distance from a point to a point is completely clear. It's this distance. But the distance from a point to a line, it could be vague. You could really say, well, the distance from here to this line here, why can't we talk about it being that distance? Well, the answer is it's convention. It's just something that we've agreed to do. When we're talking about the distance from a point to a line, we're talking about the shortest distance. In other words, if you consider this to be a big field, and this is a road, and you're wanting to walk to the road, you're standing here. How are you going to walk? You're not going to walk this long path or that path. You're going to walk the shortest distance to that road. And that happens to be the perpendicular distance. This is the path that makes the angle to the road or to the arm of the angle perpendicular. So this is how we define a distance from a point to a line. And as a kind of a counterexample, we can clearly see that if I consider this point and the perpendicular, we'll use blue here, the perpendicular, okay, so the distance to this arm, and then also the distance to that arm, we clearly see that this distance is not the same as this is. In other words, this point is not on the bisector of this angle A. All right, so now we know what a angle bisector is. What we're now going to do is actually construct one. Get rid of that. First thing we need to do, of course, is to draw an angle. Got this angle. And that, call this angle A. And what we're doing is constructing sort of how to construct the bisector of angle A. And when we talk about constructing, we're not allowed to measure things. That's the thing with constructions. You're not allowed to measure this angle, then divide that number by 2, and then draw an angle with that number that you came up with. With constructions, you're only allowed to use a compass and a straight edge. So this is how we do it. My compass, and oops, I move it over here, and then I adjust it. And I haven't done this correctly, so I move that over here. And point must be on the angle. Then I adjust it, and something like that doesn't really matter. Yeah. So good distance is good. Don't make it too close, so it becomes inaccurate. now draw like that. Then I can move it again to one of these intersection points. Before I do that, I'm going to adjust it again. Move. And I'm going to adjust it now. And I'm going to draw two arcs, one here and one with the compass here. So I want this big enough so that they will intersect. If I draw it here, they won't intersect. You're going to see that in a minute more closely. But, so I'm going to draw it like here. And I will now draw like that. I don't have to draw an entire circle. I'll now move it again. And now very important as I move it, that I do not change the setting. I don't change the setting because otherwise it won't work anymore. So I must make sure that the angle that my compass makes does not change as I move it. If it does, you must do the whole exercise again. I'm now going to draw again. And now I'm sure that this is going to be my angle bisector. I'll just blue, draw from here to here, and to make sure to put in my markings, because otherwise it won't be a real angle bisector. I have to say that these two angles are the same. This is how you construct the angle bisector.